Hello, welcome everyone. We're just going to give a couple minutes for folks to join. Welcome everyone. We're just going to wait a couple of minutes to start until folks have had a chance.
Visit go.ncsc.edu.
All right, Michelle, I think I'll keep letting people in, but I think you can get started.
Great, thanks, Addie. Hold on, they just got a lot of buttons. There's still some people in the waiting room too. Can you see that and make sure that people are admitted while I start?
Yeah, I'll keep track of that.
Okay. So welcome everyone. We're about to dive into our workshop on integrating climate information into regional fish and wildlife planning. My name is Michelle Staudinger. I'm currently on detail as a partnership ecologist with the CASC, and I'm also with USGS. I normally am the science coordinator for the CASC. And I'm joined today by my co-organizers, Ambarish Karmalkar, who is adjunct faculty in the Geo department at UMass Amherst, and Karen Terwilliger of Terwilliger Consulting. We also have two additional facilitators joining us, Tracy Rice, who works with Karen, and Tanya Buxton-Torres, who's at USGS with me on a detail as science coordinator. And we also have Sarah Wisner, who's an CASC fellow, who will be helping us today as well. So welcome everyone, and I wanted to start by going over the goal for this workshop, which is for our team to gain input on how best to scope and develop a new set of climate data products for the Northeast region to make them as accessible and usable to as many fish and wildlife managers as possible. And our agenda for today is to start off with a little bit of background on past efforts that have shaped this current initiative. And then we'll have two breakout sessions where we're going to get your feedback on specific climate data needs and applications. And the breakouts will bookend a presentation by Ambarish that gives a demonstration and examples of climate data and projections. The two breakouts are really meant to capture your input and perceptions both before and after seeing what's possible in terms of products that Ambarish has worked on in the past. And then we'll wrap up with a summary from the breakout discussions and talk about a timeline and next steps for this project. So I'm going to just jump right in and start talking about the past efforts, which started about 6 or 7 years ago, that the CASC led. And our goal was to assist state and fish and wildlife agencies to integrate climate change into their 2015 planning documents. These documents are known as the State Wildlife Action Plans. And our goal was to synthesize the current knowledge, what has been done to date in climate science in the region, as well as the knowns and the uncertainties around climate impacts. Our focus was on the responses and vulnerabilities of regional species of greatest conservation need. We'll refer to these as RSGCN, I think, throughout this workshop, and highlight the available approaches, tools, and partnerships in the region to help facilitate reducing risk. And we envisioned that this report and the associated databases would be directly used by the State Wildlife Action Plan coordinators and plan writers, both being able to just use the text to either inform their own writing or just literally copy and paste it out of the report that we produced, or to use the different databases to pick out the information that best served them. We also wanted to have some demonstrations of the applicability of different tools that we had pulled together at that time. So a little bit about state wildlife action plans for those of you who are not familiar. They are the states. They're pretty key documents and planning documents by the states that are revised every 10 years. They did one and had a deadline in 2015. And now we're approaching the next deadline of 2025. And they've both back in 2015 and now they've been challenged to incorporate climate change into their revisions. And these plans are mandated to be in place by Congress to receive funding through wildlife conservation and restoration and state wildlife grant programs. And they really serve as roadmaps for conservation in the coming decade for states. They're proactive, they're comprehensive, and they're specifically applied to fish and wildlife conservation strategies. And they seek to assess the health challenges and potential actions that each state would like to accomplish. But we know that a lot of other groups use these plans to help guide their own initiatives. So why was this tool needed? There's a lot of other syntheses and reports out there. Well, we heard from states that there was just too much. So first of all, climate change is obviously a very rapidly advancing field with new information coming out just every day, and it's very hard to keep up. And so to that, many of the states that we spoke, state agency representatives that we spoke to just said that they were inundated with information. And often it was at the wrong scale for their decision-making purposes. They also lacked often the guidance or expertise and decision support to actually apply the climate data products. They also have consistently pointed to a lack of capacity on a variety of fronts in dealing with climate change, in addition to the other responsibilities that they have on their plate. And in terms of many of the climate projections, they were overwhelmed by uncertainty, as I think a lot of us are just in general with dealing with climate change. So for the 2015 synthesis, through a co-production process with the SWAP coordinators, we developed a work plan and delivered the following. We summarized the trends and projections of over 60 climate variables for the Northeast. And the Northeast at that time was defined as the 22 state footprint that you can see on the right-hand corner of my screen. We've now since, the Northeast CASC has now since broken off from the Midwest, and the Midwest now has their own center. So we have a very different spatial footprint to look at moving forward as we look to 2025. But at the time, this report covered all 22 states. We also did a literature review and synthesis of the 367 regional species of greatest conservation need that had been identified by the Northeast region, and as many Midwest states as we could get input from. And we synthesized approximately 25 climate change vulnerability assessments that covered over 1,000 species and about 80 different habitats. We pulled together all that information and provided a comparison of the vulnerability results across different frameworks. We also synthesized just over 960 adaptation strategies into a database that could be searched by scale, target resource, climate stressor, and the National Plant and Wildlife Adaptation Plan goals. And we also provided case studies and a synthesis of tools that showcased regional adaptation and resilience initiatives. So here we are 6 years later, and the next set of revisions is just around the corner. So we have started the scoping process much earlier this time around. We were still a very new center back in 2014, 2015, having just been stood up. And so we really had a limited amount of time to do this work and deliver the synthesis for the 2015 revisions. So this time we're starting much earlier, which gives us the opportunity to do additional outreach and shaping what we do for 2025. So we've actually already been in conversations with the SWAP coordinators and the technical committees in the Northeast to shape a work plan for 2025. And what's different just a few years later is that we have just a ton of new information. We have a lot more spatially explicit climate data. We have many more risk analyses, included integrated and holistic assessments, multi-stressor assessments of risk. And we've largely moved in terms of adaptation strategies and actions from the theoretical to more examples of implementation in the region. And so we actually have data on how these projects are manifesting. And we just have a lot more examples in general of on the ground results. So we envision, again, synthesizing as many downscaled climate products and making those data and showing those data spatially explicit. Again, looking to capitalize on all the new risk assessments that have been done and look across different implemented strategies, as well as integrative case studies that can follow extreme events through sort of the downstream impacts and cumulative stressors that may have unfolded over the series of years. We also have a lot of national and cross-boundary CASC and other partner initiatives to draw from, including the BioShifts project, which is led out of the National CASC Center, which is looking to synthesize and develop a database of species range shifts globally. We can access this database and download the information for the current list of RSGCN. We also have these really great initiatives and capacity through our Future of Fire and Floods initiatives, which will help give us more information again on these integrated and extreme case studies. So we can also look on how best to optimize and regionalize climate adaptation strategies, or look to modifying existing strategies, for example, that were listed in the 2015 SWAP plans, on how best to incorporate climate change and look for similar actions across states, as well as how these strategies could be modified to better include climate change. A recent survey found that by Karen and her group found that climate change is now the #1 threat to regional species of greatest conservation need, up from the #5 threat when a similar survey was conducted in 2016. And so we can use the information from these surveys that are being done, for example, with Karen's group, to identify species that are experiencing shared climate risks, and then use spatial data to identify where they overlap in terms of different habitats and occurrence, to identify actions that benefit multiple species or can be modified to better incorporate the climate change data that we have. So now I'm going to hand it over to Karen to talk about building on this work and the utility and vision moving forward.
Thanks, Michelle. I just wanted to say a few words. I've been fortunate to have been working with NECAS and the state fish and wildlife agencies in the Northeast since the very first action plans in 2005. And I can say how hurting we were for climate change information. So if you want to go to the next slide, Michelle. We were just so excited when Michelle and her group appeared on the scene, and what we heard in the plenary session about their guiding principles on how to deliver science in the most meaningful way. It was unbelievable what happened since I'll say 2014 to 2015. to provide this synthesis to us. It was amazing. So we know CASC has been identifying climate change science needs of all 14 state fish and wildlife agencies in the Northeast, and specifically trying to provide climate change information to inform state wildlife action plans. So that has been the focus, because action plans are so comprehensive, it makes sense to start there. And the fact that we could build on the successful model of 2015 is just such an incredible opportunity. I can say I did 4 of the state wildlife action plans and was able to use just about every piece that they pulled together in this synthesis. Because they were able to work closely with us, they knew the needs of all of the elements of state wildlife action plans, and they helped match those so we could actually pull them into each chapter to meet each requirement. It was incredible. I can say that all 14 Northeast swaps did cite and use all this information. The neat thing about CASC 2 and the process we've been using is not just getting information from monthly calls, but we use the national survey. The Association of Fish and Wildlife Agencies has an annual survey. What are your science needs? What specifically do you need in what category? So we had a lot of great information from them, but Michelle and her folks went above and beyond and attended our monthly meetings. And we actually stood up a working group in the Northeast to try to get more information to make the science delivery needs really meaningful. So this go around, we're trying to build upon that and get additional information through things like this workshop. And we're hopefully trying to focus on species of greatest conservation need, their habitats, their threats, and the actions. So next slide. So it was the perfect timing, let's say. There was a need, the opportunity, and the perfect timing. State Fish and Wildlife Agencies have been working together forever, and we were able to implement all this information into all 14 state plans. So it just seemed like the perfect opportunity. And all of the swaps require regional landscape watershed information, and they also required the regional context. So it was perfectly aligned. But when I think about all this great information that was produced for state wildlife action plans, I've worked on so many other planning processes and developed so many other plans at the state, federal, and local level that it just occurred to me that this information is usable for anyone, any planning process, any manager that works to identify conservation targets. Climate change data is needed for anyone who works with species or habitats and trying to identify the threats to them. So just from my experience, I know I've done a lot of U.S. Fish and Wildlife Service work with comprehensive conservation planning for national wildlife refuges. There are sections in there that require what's the existing conditions, what are the projected future conditions, climate change predictions fit perfectly in there. Doing species status assessments, environmental impact statements, biological assessments. We need to assess what's there, and climate change is now a really big aspect of that. I've worked on lots of Department of Defense planning, integrated natural resource management plans. They also require what are the current conditions, what do we project future conditions to be. These are the variables that Ambarish is working with. This is what we're trying to get refinement of with your help today. Other plans, Department of Transportation, they need to include climate change in just about everything they do. And tribal grants and plans. This is really important, not just culturally, socioeconomically, and environmentally. Another set of plans, forest action plans, they require sensitive species. They list sensitive species. Well, climate change affects them and their habitats as well. NRCS, folks who put action on the ground for agriculture and forestry, Soil and Water Conservation Districts, Department of Agriculture's Environmental Protection Agency with water quality assessments. There's so many different plans that need this to really adapt, adopt, and implement this climate change information. So what was done for state wildlife action plans is really useful across the board. And let's not forget at the local level, how many comprehensive county plans or local plans need this information as well. I've just found the work that NECAS has done for the swaps to be so interchangeable in any of these plans. And I really just encourage everyone to use them and help communicate through this process and others what are the important aspects of the science that you need so that we can get that information to you.
So now we're going to hear from Ambarish, who's going to introduce the goals of our first breakout.
Thanks, Michelle and Karen. I think you've really talked about, all the important things that we need to be thinking about while thinking about how to create climate information. So I'm going to be talking about giving a brief overview of the climate work that we've been doing. And my talk is sandwiched between two breakout sessions. The first one is just to get your input on the climate science information needs that you have. And then the next session after my talk is going to be more targeted. And that's where you can talk about, the specific needs that you have based on the preliminary analysis that I'll present. So the goal of the first breakout session, there are two questions that we will discuss. The first one is, what entity do you represent and what plans, decisions do you envision needing climate information for? And then the second question is, if there were no limitations on what was possible, what climate information do you need? Do you really need to make effective decisions? So I think this is the idea of this breakout is just to get an input without telling you what information we can produce so that, we can really understand what your needs are and think about ways to refine a climate information better. So
before we go to the breakout rooms, does anybody have any questions for Karen and I, just from our initial talks before we go to breakouts? Okay, so hearing none, Ambarish, you want any final thoughts before you send us off to our breakouts?
We could go ahead.
Next, we're going to hear from Ambarish on some examples and demonstrations of climate products that he's been thinking about. Ambarish, are you able to share your screen?
Yeah, I'm doing that.
It's just about co-presenting capabilities. If not, I can share mine. Great.
Can you all see it fine?
Yes.
Okay, perfect. So I'm going to take the next about 15 minutes to talk about the work that we are undertaking to produce climate projections for the Northeast US. And so I'm going to be working very closely with Michelle and the SWAP coordinators to figure out, what's the best way, what's the effective way to create these climate projections. And today, what I'm going to do is to give you a quick background of the preliminary analysis that we've done to produce these projections. Oops. Give me a second. Oh. I don't know what my screen is doing. Do you see the presentation now?
Yes.
Okay.
Yes.
Okay. So So this is a 2-year project. The title of the project is Enhancing the Reliability and Usability of Climate Change Information for Wildlife Action Plans in the Northeastern US. And so it really has 2 components. The first one is the reliability of climate information, and the second component is the usability of climate information. So the reliability of climate information really depends on coming up with the best possible science to be able to inform some of these projections. And the usability is about working with the users of climate data to find ways to make these projections and the basic climate information useful. So in terms of the reliability, we're doing a lot of work to understand the underpinning science. If you look at the temperature change in the Northeastern US, you see that the mean annual temperature has gone up by about 2.5 degrees Fahrenheit, or about 1.4 degrees Celsius in the last 125 years. And the rate of warming that we've experienced in the region is higher than the global average temperature rise. So in a nutshell, we are warming at a faster rate in the Northeastern US. But this warming that we're experiencing is not necessarily, it's not constant throughout the Northeast. The figure on the left-hand side shows you the amount of warming that's experienced over the entire contiguous US. And you can see in the Northeast, it's the coastal regions and the northern part of the Northeastern US has warmed more in the last 120 years compared to the central and western parts of Pennsylvania and the New York State. And so what we're trying to do is, while focusing on the Northeastern US, we're also focusing on these region-specific trends in temperature and other variables to understand how different these variations are across the region. In some of the work that we've done earlier, we found that the Northeastern US is actually one of the fastest warming regions in the contiguous US when you look at future projections. So what this figure on the right-hand side is telling you is that about 80% of the model projections that we use indicate that the Northeastern US would reach 2 degrees Celsius warming above pre-industrial levels by 2040, whereas the global average temperature takes 20 more years to reach that 2 degrees Celsius temperature threshold. So we are warming at a faster rate. We are also trying to understand some of the reasons, some of the drivers behind this enhanced coastal warming. And we had a study published earlier this fall, just a month ago, which connects what's happening in the Gulf of Maine, in the mid-Atlantic Bight region, in terms of sea surface temperature change, and how that might be affecting coastal temperatures along the Northeastern US. And Michelle and her collaborators are working on the impacts of the Gulf of Maine warming on fisheries and marine aquatic systems. And what we're finding is that region, the ocean dynamics that's affecting that region, also has an impact on some of the trends that we see in the Northeastern US. So this really helps us understand what are some of the controls and what are some of the drivers of climatic changes that we experience in the region. Looking at rainfall, precipitation over the last 120 years, we see a clear trend towards higher precipitation. This essentially what this figure shows you is how precipitation has varied since 1895. And you see that precipitation is highly variable from season to season, from year to year. And yet the trend towards increasing precipitation is now quite clear in this figure, especially since the 1970s. We had this huge drought in the 1960s in the region, and then since then we do get years with below normal precipitation, but overall the amount of precipitation we get now is significantly higher than 20th century. And I'll talk about how that trend is going to go in the future. So how do we really go from climate information that we get from climate models to producing something that can be used to make decisions? Essentially, all the climate models that we use are developed by modeling centers across the world. They make the simulations and all their data publicly available. So in that sense, we really have access to a lot of climate information. But the problem is that most of these models produce information at very coarse resolution, about 100 to 150 square miles. And so that doesn't really help us understand what's going to happen at regional scales. So what we do is we take information from these global climate models, we go through a rigorous assessment of these models to make sure that they are able to capture the patterns of temperature and rainfall changes that we see in the region, as well as some of the drivers of those changes. We want to make sure that these models are physically sound models to be able to give us useful information for future projections. And so we go through the rigorous assessment of these models and use that information to select some of these models that are really reliable in producing regional scale information that is useful to us. But even then, we have to then downscale that information to local scales. I mean, one of the things we heard from the previous breakout groups is that we really need information at local scales to be able to make effective decisions. And so there are various downscaling techniques that one can use that combine observations at local scales and use that information to downscale model data to very high resolution. We don't have time to get into these downscaling methods, but one of the motivation of the project that we are working on is to assess the reliability of some of these downscaling methods, because there are potentially various different ways of downscaling climate information. And we want to make sure that the information that we're using is capturing, say, precipitation variability in the region, as well as precipitation extremes that are really critical. So essentially, the flow chart of information looks like this. You have some scenarios of future emissions. We have to come up with scenarios because we don't really know how things are going to change in the future. And so we come up with different scenarios of future emissions. We use these climate models to come up with future scenarios of temperature and precipitation changes and changes in other variables as well. We take that information, we downscale it to local scales, and then we work with the managers, the ecologists, the hydrologists to produce information that can be used in management decisions. So I'm going to jump into the second part is, and that is really producing climate projections at local scales. And I did this work in collaboration with the Massachusetts Executive Office of Environment and Energy a couple of years ago. And so I'm going to show you examples from that. And what we're going to do is to use this idea, the methods that we've used to produce information for Massachusetts, and then as well as feedback that we get from you to be able to produce information for the entire Northeast region. So for Massachusetts, what we did was to use climate data from the CMIP5, the latest generation of climate models. The downscaled information was available at 6 kilometer resolution at daily time steps. And then we use two different scenarios of future emission. One is sort of the middle of the road scenario, and one is the worst case scenario where the emissions continue at the current rate or at the modern rate. And then we produce projections of climate information at the state level, at the county level, as well as at the watershed level. And then the available variables were that included temperature variables, the mean temperatures, as well as extreme temperatures. So you have, number of days with temperature over certain threshold, as well as heating and cooling degree days that are important for energy consumption, and then information about growing degree days accumulation, which is important to understand the growing season and so on. And then we also created projections for mean precipitation, seasonal mean precipitation, as well as precipitation extremes. And so I'm going to give you quick examples of how that information was presented. So here's just looking at temperature projections for the state of Massachusetts. Sorry. The top left shows your time series plot where you have observed temperature shown in black, and you have simulated temperature into the future shown by these blue and red plumes. And those plumes basically show you temperature projections for different scenarios. So essentially you can see the range of projections consistent with all the uncertainties that we have in climate modeling, by the end of the century. And then you can also separate that information out in different scenarios. If you were to follow medium emission scenarios, where would that take you? The other way of presenting information is to look at spatial maps. And so on the leftmost map shows you absolute temperatures over the modern period. And you can see that, typically coastal regions are slightly warmer than the interior Massachusetts. But then the next two panels show you actual projections on top of that climatology. And you can see that more or less the entire region, you would experience a similar level of warming on top of this base climate that we experience in Massachusetts. What's most striking is when you look at extremes, and temperature extremes are really important when you think about the difference between different scenarios. So for example, summer daytime high temperatures rarely go above 95 degrees Fahrenheit in the region. And what these two panels is showing you is how that number is going to change in the future. And if you just focus on the right-hand side panel, by 2090s, you could say that in the medium emission scenarios, we would only experience 5 more days by the end of the century with temperatures, summer high temperatures above 95 degrees Fahrenheit. But if we were to continue on a high emission scenario, then that number goes up dramatically. And so this really highlights the importance of mitigation. That if we were to, curb emissions, then, in terms of, we would avoid really extreme temperatures in the region. And so we can produce this information at local scale, essentially, to be able to assess what the impacts are. Precipitation projections, it's similar presentation to what I showed you for temperature earlier, but as you can see, that precipitation is highly variable, and it's a difficult variable to simulate in general in these climate models, because it really depends on a lot of complex factors. So the models need to be able to simulate many different factors correctly to be able to get the precipitation right. But as you can see, the observations lie, within the envelope of model simulated precipitation over the historical period. And when you look at future projection, you can barely see that increasing trend in precip throughout the century, but there is not much difference in that blue region and red region. And what that means is, since models give us very different precipitation numbers in the future, the difference between using two different scenarios is not very high. And what that means is, for us, climate scientists, we really need to use diverse set of models to be able to provide information on different futures that we might experience here in the future. And again, these plots at the bottom show you, the maps of precipitation change, and the blue or violet colors indicate increase in precipitation during the middle of the century as well as by the end of this century. We can also break it down in terms of different seasons, because much of the precipitation increase that has happened in the region has mostly happened in the fall season, at least so far. So we are trying to, we just won't provide annual mean, precipitation change, but we'll break it down and provide information for different seasons as well. This is just an example showing, the changes in a number of days with precipitation over 1 inch for the Suffolk County. And what this panel on the left shows you is that currently, at the moment, in this particular model, we experience about 5 days per year with precipitation above 1 inch in the Suffolk County. And in the future scenario, that number would double or even triple by the end of this century. So again, we're able, using high resolution downscale data, we're able to provide information at that scale. And then a couple of examples of how this information is being used. So again, in the breakout session, there were questions about, taking climate projections and then using those to understand how that would impact river flows or stream flows. And so, the climate projections that our group produced were used by hydrologists at UMass to produce, to understand how that would impact, how extreme precipitation would impact stream flow and river flow. And these are just projections for the near term, for the next 40 years, and then the last 40 years of the century. And all the blue circles here indicate that the flow would increase in those regions in the future. And that really depends on the increase in precipitation that we see in winter months. And another example is using the models that we selected to assess the changes in maple syrup sap flow in the future. And so this was work done by Joshua Rapp and collaborators, showing that essentially, there's going to be decrease in sap volume because those are highly sensitive to freeze and thaw cycles in the spring season. And so we were able to use climate data, or rather they were able to use our climate data to be able to produce information on how sap volume would change in the future and what would the spatial distribution of that change be. So those are some of the examples. Essentially, just to summarize how we would do this, as I said, climate projections will be provided at a number of different scales that we identify, but it could be ecozones, or it could be county scale information, or watershed scale information, or we would love to hear from you about what those scales might be. A lot of the temperature and precipitation related information is going to be quantitative in nature. We would provide projections for the near term, for the middle of the century, as well as for the end of this century. But then we could also use the existing literature to provide qualitative information on things like humidity levels, snow cover changes, or there might be people who are interested in sea level rise projections along the coast. And then we'll have a final report containing key graphics similar to the ones I showed you. We will also work on creating summaries, or providing interpretational background on some of those projections, so that users can develop insights into the impacts. And then finally, the idea is to work with many of you over the next couple of years to come up with case studies that sort of integrate climate information and its interpretation and its actual use to make decisions. So I will stop there. If you have any questions about this piece, you can, or the studies that I mentioned, feel free to email me. My information will also be on the last slide at the end of the workshop. So I'll stop there. And Michelle, do you want to introduce the next breakout session?
Yeah, if you could stop sharing your slide.
Oh, yeah.
The questions. So thank you, Ambarish. I think we're going to move right into our next part, which is the breakout rooms. But I did want to just give Ambarish a chance to, a couple questions came in. And first to Sally Ann's question, the answer is yes. We have a number of projects that are taking these climate data and integrating them into habitat change. So we've had several PIs at the CASC, like Frank Thompson and Tony D'Amato, who have taken a lot of these climate data and integrated them into forest change models, as well as in other places as well. But Ambarish, I was hoping you could speak to Mark Bellis's question. You did kind of cover, how there's a lot of uncertainty in precipitation, but especially in the Northeast, where we're having this sort of oscillation between extremes of short-term droughts and then extreme flooding. Maybe you can speak to how climate scientists take the sort of, real-time manifestation of climate impacts and integrate it into understanding and tightening the bounds around that uncertainty. I think that'd be an important thing for us to talk about before we jump into these breakouts.
Sure. So I think, I'm looking at the questions, looking at the question by Mark, and it's also talking about, climate projections related to drought. That's also because that's related to the high variability that we see in precipitation. That because of that high variability, you could have short seasonal droughts. We experienced one in 2016. It is really difficult to quantify some of those uncertainties in the models. What we are finding is that we did a lot of work on that to understand what are some of the underlying processes that are important for high variability in precipitation in the region. And we looked at these models and we tested these models to capture different processes that determine precipitation, especially summer precipitation in the region. And then we ranked those models based on their performance. And what we found was the top 6 climate models in terms of their performance out of the 36 models that we had analyzed had very different summer projections in the future. What that essentially means is that even though you understand climate model performance and try to make sure that these models are doing the right things for right reasons, it's really difficult to constrain and narrow that uncertainty in the future. And so my approach or my thinking about this is that this assessment of models really helps us understand which models are reliable, and then we use those models to see what they do in the future. That would give us an envelope of projections into the future, which might not be narrow, but it's an envelope that we think is represents plausible futures that we might experience. And so the way we'll have to work with that information, uncertain information, is to do risk assessments, to assess, whatever the decisions that we're trying to make or the species that we're trying to study. We'll have to see how those different futures are likely to affect the studies or communities under study, and then make decisions based on that. But I think I'm not confident that we'll be able to constrain those projections further, especially at very high regional scales. I think if you're looking at a broader scale, continental scale, there are ways to constrain and narrow uncertainty. But for decisions, we unfortunately have to rely on very local climate information. And unfortunately, at those scales, the uncertainty only grows.
Great, thanks. So now we're going to get into our second breakout, and we've got 2 questions again. We'll take about 18 minutes to work through these 2 questions, and then we'll do some final wrap up in the last few minutes of this workshop. So Addie, you ready to send us off?
Great, yeah, and come back at 3:20, Michelle, is that right?
I think we can do 3:22.
Sounds good. All right, and Ambarish, you should be able to record now. All right, bye-bye.
All right, thank you, everyone. That we had some great discussion in my breakout room, and Karen and Ambarish and I are each going to just share one major takeaway from our breakouts. The recurring theme that I heard in my room was just that water is so important at many different scales, whether it's the watershed scale, the river scale, thinking about it in terms of barriers, in terms of dams. In terrestrial environments, it's also important at the subsurface level. Everyone was talking about water. And so, that is from thinking back to the earlier presentation, that is the amount of water that we're going to get, and the rate that we're going to get it at is one of those big uncertainties. And so it seems like a lot of people are grappling with that. Ambarish, do you want to share next?
Yeah, I think one of the takeaways from my breakout session was that producing information for ecoregions is going to be critical, because I think ecoregions capture the spatial variability related to water as well as elevation, and so in terms of when we were talking about scales at which the information would be most useful, what I heard was that producing information for different ecoregions, I think would be really helpful to people.
And Karen.
Yes, it was interesting to hear how many different goals produced a different answer. Some were species focused, some were habitat focused, and again, aquatics really rang true. But an interesting comment on the scale, and if there were no limitations, a way to get to any scale would facilitate someone being able to go onto his web portal and interactively draw their own polygon to get to their own scale that they would like to use. So that was the no limitations comment. So folks took that seriously, but that would be ideal. Had a lot of great discussion.
Great. Well, just to wrap up, I wanted to talk about where we're going from here. So Ambarish already kind of talked about a little bit about the climate delivery that he envisions with his specific project. And overall, for thinking about, as Karen and I talked a lot about in the beginning of the workshop, all of this outreach and scoping is meant for the primary purpose of designing a new synthesis report and set of products for the 2025 State Wildlife Action Plan revisions. And so I wanted to just sort of give you a sense of when we're expecting to roll out the results. And even though the revisions are due in 2025, we're working backwards from that and thinking about when we can deliver the products to inform the writing of those plans. So we're really seeing a sort of rollout of information in a couple different parts starting in spring 2023. We'll also expect that we'll have an CASC webinar where we'll kind of give a presentation just explaining everything that we did and where to find those products. We did something similar when we did the 2015 revisions, sort of a roadmap presentation to what we did and where to find it. And then we'll handle that information over by the end of 2024 to the states for them to pick up and use as they like in their writing, and then final delivery of the reports. Karen's going to say just a few final words about how to stay engaged with this team.
Yes, and the wonderful part of all of this is the time scale that Michelle just displayed. This isn't our only chance for input. Thank heavens we have a lot more time and a lot more opportunities to engage with NECAS. And we heard during the plenary, delivering the most meaningful science that meets everyone's needs. Well, this is your chance. We talked about what kind of information, what scales. There'll be a lot more opportunities for engagement, and specifically, we've started up a Northeast Climate Change Working Group, and we have monthly calls. If you are interested in jumping on those, if you're not already on them, please let us know and we could add you to the list. There's also a project steering committee. There's mostly state wildlife action plan coordinators, but we can add folks if you're interested. We will also, most likely from this entire symposium, have follow-ups and post-workshop questionnaires. So you will be hearing from us, and we'll ask you specific input, feedback. Now that you've had a little chance to think about this, how more specific can we get? And again, email us anytime, and our contact information is right here. If you have any other thoughts, please contact any of us.
Yes, thank you so much to my co-organizers. I also wanted to mention that we have a fantastic website that has specific project pages that you can find all of the past products that my collaborators and I have pulled together. So if you go to our main landing page and click on science, you can search different keywords to find information about all of our projects. But if you want to learn more about the things that we've been talking about today, you can type in the keywords action plans, and it'll bring up a list of projects for you to choose from. So the oldest being the older ones showing where Karen and I have been working on for the last several years. First on integrating climate change into the 2015 state wildlife action plans. You can access the report and all of the databases that we pulled together 6 years ago. And then the work that Karen has been doing since then to engage and do outreach with the different state agencies, and some of the lessons learned and different survey results that she and her crew have compiled. And then the most recent projects being led by Ambarish, and I'm sure we'll have a project page for this specific new broader effort for 2025 as well. So thank you everyone for joining today. We really appreciate all of your input in helping us shape this effort. And we have a collaborative session that is starting after a 15-minute break at 3:45, where we hope you will all rejoin us for the final session of our second ever Northeast CASC Regional Science Meeting. So thank you, everyone.